Hello, 8th grade science students. Today we're going to work on making covalent compounds again. This time we're just doing a little bit of practice. I'm going to do 2 example molecules for you, and then we'll take a look at how the worksheet works so that you can see how you're supposed to do that. The worksheet's going to be posted. It's something you should either print or you could complete on a separate piece of paper, and then I'll hopefully be posting the key so you can check your own answers tomorrow. Okay, so making covalent compounds practice. Here's kind of the key 2-step process, and it's not super complicated. It can get relatively challenging depending upon the elements involved. So step 1 is to make the Lewis dot diagrams. That way you know how many electrons you need to be pairing up. And step 2 is to share those electrons and pair them up until all atoms involved have a full valence shell. Okay, so let's take a look at an example. Let's take a look at silicon and oxygen. So I'm going to draw the Lewis dot structures for these first. If we look on your periodic table, silicon has 4 valence electrons. It's just below carbon. So silicon's Lewis dot diagram looks something like this. Oxygen has 6 valence electrons, and therefore its electron dot diagram looks something like this. So oxygen has 2 electrons that aren't paired up, and silicon has 4. Now, so there's 2 different ways these problems can go. I might give you the complete formula so you know how many atoms of each element there are. And there are some situations where it's just going to give you 2 elements. You got to figure out a molecule that works. There could be more than one correct answer to this. And generally speaking, there is. But to keep it simple, I try to use as few as I possibly can. So the thing that's kind of obvious to me right away is that oxygen has 2 that need to be paired up. Silicon's got 4. So the nice thing is that that's some nice math there, right? So if I have an extra oxygen, I have 4 electrons from oxygen that need to be paired and 4 electrons from silicon that need to be paired. So let's just start with 1 oxygen. I'm going to kind of turn the electrons on the silicon so it's easy to pair them up. The oxygen I will also turn, so 1, 2, and then the 2 pairs of stable electrons. And those are going to bond together right here. So that is 1 double bond between the oxygen and the silicon. Let's go ahead and finish this off. We're going to make 1 more oxygen on the other side. And we can pair those off as well. So here we have a molecule of silicon dioxide. And we now know a little bit more about it, not just that there's 1 silicon and 2 oxygens, but that there's actually 2 oxygens double bonded to a silicon kind of in the middle. So there's one example. Let's look at one more. A little bit different. So we've got now 3 elements, but we know exactly how many there are. I've told you there's 1 carbon, there's 4 hydrogens, and 1 oxygen. Let's go ahead and draw the Lewis dot diagrams for these. So carbon looks a lot like silicon. It has 4 valence electrons. Hydrogen just has 1. Oxygen has 6, just like the last problem. Okay, this one's a little bit trickier, and one hint I can give you that this is methanol. And one thing you could do if you want to is pause the video and try this on your own. The nice thing is that we do know exactly how many atoms we've got. 1 carbon, 4 hydrogens, and 1 oxygen. So now, one thing that's a little bit tricky is if I start bonding hydrogens right away, we'll end up with methane and the oxygen won't have a spot to go. So that means I can't bond, I'm going to have to bond at least the oxygen at least once to the carbon. And there's a temptation to double bond that oxygen. We are going to kind of avoid that temptation because we also need another spot to put that 4th hydrogen. If I double bond the oxygen, there's only 2 more spots for hydrogen to bond. So let's do oxygen as another color again. So oxygen, 1, 2, 3, 4, 5, 6. Now you notice I've done something a little bit different here, which is that I've put the single bonds on the other side of each other, or the individual electrons, so they don't get caught up. Now I have, which is kind of nice, I have 1, 2, 3, 4 electrons not paired up, and I need these hydrogens each to get a buddy. So there's 1, there's 2, there's 3, and there's 4. And we can complete this by circling these electrons to show that they are indeed creating single bonds. So we have a carbon bonded to 3 hydrogens and an oxygen, and the oxygen's spare electron is bonded to the hydrogen on the outside. So this one's interesting where it's a little more complicated, but it is all single bonds. There's no double bonds there. Okay, let's take a quick look at the worksheet and how that's going to work. Worksheet looks something like this. So covalent bonding with Lewis dot diagrams. So part of this is just practice. So I really want you to draw all the dot diagrams. Now, if you want, so the fluorine, which has 7, obviously they are both going to be the same. So you can write the same and put an arrow there. That's fine. If you'd like to redraw it, because then you have all the atoms you need, then you're good. So you're going to get 2 elements. You've got to figure out a way to put them together. So you get 2 boxes to draw the dot diagrams. The third box is for you to create the compound dot diagram. And you'll notice that fluorine, they each have 1 unpaired electron, so they just pair up to form fluorine gas like that. And then finally, your job is to draw the molecular formula. So you got to count up the number of each element and draw and write the molecular formula for me. The only element I have in this one is fluorine, and I have 2 of them, so the molecular formula is F2. I will have the key for this finished and posted for you guys tomorrow. Thank you guys for listening. Good luck with the worksheet and the assignment, and as always, stay safe and healthy out there.